Hello guys, what's up? I hope you guys are having a wonderful day ahead. Okay, so the topic for today that we are going to discuss is reciprocal leveling. Yeah, so let's begin. Okay, first of all, let's discuss why do we need leveling. This earth ain't a flat place, so leveling plays an important role in that. Now, one of the method of leveling is reciprocal leveling. Yeah, so what is reciprocal leveling? Reciprocal leveling is a method of leveling to accurately determine the difference in elevation between 2 points that are considerable distance apart with an intervening obstacle such as a river, as the level cannot be placed between them to balance the lengths of the lines of sight. Reciprocal leveling is adopted. Yeah. Let's see what are all the instruments used in reciprocal leveling. The first one is the level staff. The next one is the tripod stand. Over here something is going to be placed. Let's see what it is. And the thing which is going to be placed over there is the auto level. Yeah. Now, what is the principle of reciprocal leveling? Yeah, the figure shows the basic principle of reciprocal leveling. A and B are 2 points that are situated between a river, which is an obstacle over here. The objective is to find the difference in elevation between points A and B accurately. As shown in the figure, the level is set up near A on the line AB produced. The instrument is leveled and readings taken on the staff held at A and B. As the level is very close at A, the reading have to be taken by looking through the objective glass with the eyepiece pointing to the staff held at B. The error in reading on A is practically zero due to the inclined line of collimation and curvature and refraction. The reading on the staff held at B is considerable as the distance is large. Let A1 and B1 be the readings taken. The reading at B is in error by an amount of E due to the effect of curvature and refraction and the inclined line of collimation. Yeah. In the second step, the level is shifted to a point close to B. Okay, as shown in the figure, it's over here. On the line AB produced, it is set up and leveled. Readings are taken on the staff held at A and B. The reading on B may have to be taken through the objective glass as the distance or to the staff is very small. Let A2 and B2 be the readings on the staff held at A and B. The reading on the staff B is practically without error as distance and the effect of curvature and refraction as distance from the level is very small. Sorry about that. The reading A2 is in error due to large distance and the effect of curvature and refraction and the inclined line of collimation. Let E again be the error in the staff reading at A. The two errors, this one and this one, are equal as the distance involved is the same. The corrected readings are as follows. Before looking at the corrected readings, let us have a look at error due to curvature and refraction. The earth is in a flat place, so due to the curvature of the earth and due to the atmosphere, error is caused due to curvature and refraction. Next, collimation error. Okay, now let's have a look at correct readings. Instrument at A. On staff held at A capital is considered as A1. On staff held at B, the reading will be B1 minus E, where E is the curvature correction, minus refraction correction. Sorry about that. Over here it's minus actually. It's curvature correction minus refraction correction plus correction due to incline. It's plus or minus correction due to inclined line of collimation. Assuming a fall from A to B, True difference in elevation is nothing but A1 minus B1 minus E, which will eventually give you A1 minus B1 plus E if A is lower than B. Now what if the instrument is at B? On staff held at B is equal to B2. On staff held at A is equal to A2 minus E. True difference in elevation is given by A2 minus E minus B2, which will eventually give you A2 minus B2 minus E, assuming a fall from A to B. True difference in elevation is equal to A2 minus E minus B2, which will eventually give you A2 minus B2 minus E if A is lower than B. Adding the two corresponding equations in the either case, we will get this equation. 2 into true difference in elevation is equal to B1 minus A1 plus B2 minus A2, or the formula can be written as A1 minus B1 plus A2 minus B2. I hope guys you understood the principle behind reciprocal leveling. Now let's.
Reciprocal leveling is not just about taking points, staff readings at A and B or P and Q. It's after that you have got to solve the equations. Now here is an example which will make it all clear. The following readings were taken during reciprocal observations to find the difference in elevation between 2 points A and B. Determine the true difference in elevation between them. It is given that the reduced level of A is 128.945 meters and we have to find the reduced level of B. So here's the solution. With the instrument at A, level difference is equal to 1.965 minus 1.345. Which are the staff readings of A and B as looked at from A, which will give you the answer as 0.620 meters. Now at B, level difference is equal to 2.015 minus 1.525, which are the staff readings of A and B as viewed from B, which will give you the answer as 0.49 meters. Now, what's the true difference in elevation? True difference in elevation is given by level difference at A, level difference at B, 0.620 plus 0.49 divided by 2. So our answer will be around 0.555 meters. This is a fall from A to B. Therefore, reduced level of B is equal to reduced level of A, that is 128.945 minus 0.555. The calculator tells us the answer is 128.390 meters. Yeah, this is just a simple example. The next one is going to be a bit complicated one. So here it is. The following readings refer to the reciprocal level taken between 2 points, 2 stations P and Q. Find the true difference in elevation between P and Q. If the instrument has a collimation error of 0.003 by 150 meters and the distance between the station was 1150 meters, find the error due to refraction. We have to find the error due to refraction. The collimation error is already given. So here it is. The apparent difference in elevation with the two settings are the following. With the instrument at P, difference of elevation is given by 2.724 minus 1.425, which are the readings of P and Q as viewed from P. The answer will be 1.299 meters. With the instrument at Q, difference of elevation is equal to 2.504 minus 1.429. The answer will be 1.075 meters. Now, what's the true difference of elevation between P and Q? So the true difference is given by 1.299 plus 1.075, which are the difference of elevations from point P and point Q respectively, divided by 2. The answer will be 1.187 meters. Now, in the question, it's given that collimation error is given. We have to find the refraction error. So the collimation error is equal to 0.003 as given over here in the question, divided by 150 for D, which is 1150 meters. We can write 1150 meters as 1.15 kilometers also. Okay, so here it is 0.003 divided by 150 into 1150. So the answer will be, the collimation error will be about 0.023 meters. Now, due to the curvature of the earth, there will be an error. We have to find that error too. Now, that is called as error due to curvature. Is given by 0.0785 d square. We know that d is nothing but 1.15 kilometers as said earlier. 0.0785 into, the answer for this will be 0.104 meters. Okay, now we found the error due to curvature. Now we have to find the correct reading at Q with placing the instrument at P. At P, with the instrument at P, correct reading at Q is equal to 2.724, which is the staff reading at Q as viewed from instrument placed at P, minus 0.104, that is the error due to curvature, minus R, that is error due to refraction, minus 0.023, which is the collimation error, this one, 0.023. The answer for this, okay, so this is the thing, the answer for this, the true difference in elevation will be will be as follows: 2.724 minus 0.104 plus R minus 0.023. We consider this as equation 1. Now we have to find the correct reading on P with the instrument at Q. At Q, correct reading on P is equal to, is given by 1.429. That is the staff reading at P as viewed from Q, minus 0.104, this is the error due to curvature, minus R, that is error due to refraction, minus 0.023, which is the collimation error. 0.023 is the collimation error. Now the true difference in elevation is given by 2.504, that is the staff reading at Q as viewed from Q itself, minus 1.429 minus 0.104 minus R, that is the error due to refraction, and this is error due to curvature, minus 0.023. After solving this, we'll get 1.202 minus 1.202 minus R. This is considered as equation 2. Now we have got to find R, that is error correction due to refraction. Now we have to equate equation 1 with equation 2. The equation 1 is 1.172 plus R. We have to equate this with equation 2, that is 1.202 minus R. Okay, so R will be 0.015 meters. This is correction due to refraction, which is equal to 0.015 meters. This problem is done. I hope you guys understood it. Now let's move further.
Okay, now we have looked into a few examples based on reciprocal leveling. Let's move further. Let's look at the problems that arise while we do leveling. During fieldwork, one may come across many situations in which to continue leveling work accurately, some innovative measures has to be taken. The following are some of the common difficulties faced during fieldwork based on reciprocal leveling. So the first one is leveling across the lake. It is possible to go around the lake or pond, and hence leveling across it is not a big problem. If going around an obstacle is cumbersome, leveling across can be done by taking advantage of the water surface, which is a level surface when still. On either side of the lake, stout pegs are driven with their top surfaces flush with the water surface. Readings can be taken to the staff held on top of the pegs from either side. The two pegs begin at the same level. The heights of collimation of the instrument stations on either side can be related. Okay, this was one of the problems. The next is leveling across a river. So to continue leveling across a river, reciprocal leveling is the best method if the staff on the other side can be sighted without difficulty. If this distance is too large for sighting comfortably, then the method of using the still water surface, as in the case of lake, can be employed. One has to find suitable points across the river on opposite sides where the water is still and pegs can be driven from taking readings. So that's it for today, guys. We have covered the basics of reciprocal leveling, and yes, I hope you have a great day ahead. Thank you.